Copper is the oldest material used by humankind. This durable and versatile material is used for domestic and industrial purposes. Clearly, copper is an integral part of our everyday living. From cell phones to the roofing of public institutions and electric power lines, copper plays a key role in our lives. Recyclable materials in concentrate contain copper, precious metals, sulfur, and iron. This diagram represents the flow of materials processed at Horne Smelter. Copper and precious metals emerge as anodes at the end of this transformation. In the concentrator, iron will be extracted and safely stored in our tailings and our pond areas, and sulfur will be captured and converted into sulfuric acid. Firstly, we must properly receive the material. Each year, over 740,000 tons of copper and precious metals bearing concentrates are sent to our smelter. We receive this concentrate in powder form containing 10 to 40% of copper. We are the leaders in meeting the needs of international mining companies. We receive over 100,000 metric tons of recycled materials consisting of any products that may contain copper or precious materials. The Horne's processes can handle a wide range of materials, from obsolete printed circuit boards to manufactured copper products. All these materials contain copper and precious materials. Once they have been refined, they will manufacture new products, hence giving metals a new life. Our customers can choose to handle a variety of materials by ocean freight, by rail, or by road. No matter the mode of transportation, operations are handled safely and efficiently. To ascertain the accurate weight of delivered materials, each transport unit is weighed using a certified scale before and after unloading. Sampling is then carried out. Our sampling techniques, renowned worldwide, vary depending on the type of material. A team of engineers and technicians constantly monitor quality control through a systematic statistical approach. For example, to ensure precise sampling of the concentrates, 3 pipes collect matter in various locations on the railcar. An automatic sampler also captures a representative portion of recyclable materials in a conveyor chute, representing the entire load. The objective is to obtain the most accurate sample of the delivered material. Utmost attention must be paid to ensure the sampling process's reliability and maintain our reputation for integrity. Our process makes producing multiple sample bags possible. One of these bags will be kept if independent experts must double-check sample content. A second sample bag will go to our laboratory. In the laboratory, the bag's exact metal value will be determined to ensure that our customers receive what they had requested. The laboratory team uses the most modern techniques to provide quality, precise, accurate, and prompt analysis. Our technicians and chemists process over 55,000 samples per year, including samples used to control our extraction process. Our technicians and chemists are aware that these results directly impact our production operations and customer value. The recyclable material is now ready to be taken by conveyor and fed into the Noranda reactor, a technology developed by our research and development team in 1973. Materials are projected into the vessel by a high-speed slinger. The vessel is heated at 1,200 degrees Celsius, making it possible for materials to liquefy. The purifying process consists of injecting oxygen-enriched air. Firstly, oxygen binds to the sulfur and the iron contained in the material. Secondly, sulfur forms a gas phase on top of the vessel. Beneath the gas phase lie 2 liquid metal layers: the slag containing iron, silica, and about 4% of copper, and the matte beneath the vessel made of 70% copper. The molten metal will then be transferred to the second stage, the Noranda converter. First operated in 1997, the Noranda converter is the result of hard work and ingenuity by our process research and development team. The converter enriches the matte reactor to a content of 98% copper. Once the copper has been boarded in the Noranda converter, the matte forms an intermediate phase called white metal, whose content is 80% copper. The white metal is further oxidized to free copper from the sulfur and create a semi-refined copper at 98% content. This copper will go on to the third stage of purification, the desulfurization vessel, where the last traces of sulfur are eliminated through oxidation at a temperature of 1200 degrees Celsius. The molten copper is then sent to an anode refining furnace. At this stage, natural gas is used to remove any remaining oxygen from the desulfurization vessels. Now that the copper has reached 99.1% purity, it is finally cast into solidified anodes that are cooled with water. The remaining materials in the anodes contain highly valuable metals such as gold, silver, platinum, and palladium. The anodes are transported by rail or truck to the CCR refinery in Montreal. This plant proceeds to the final refining stages of copper and other precious materials, producing byproducts such as selenium and beryllium, copper, and nickel sulfates. The final refined copper product is a cathode that has reached 99.9% purity and is sold on world markets. These value-added products are delivered into two processes, the concentrator and the sulfuric acid plant. The slag resulting from the smelting of materials still contains large quantities of coppers and precious metals. Because of the slag's slower density, it floats on a molten matte surface and is poured into ladles, transported to a controlled area by specialized heavy equipment. The slag is set under cool water showers for 30 hours. During this process, a steam cloud can be seen rising. Once the slag is hardened, it is taken out of its ladle and crushed. And the slag lumps are reduced to fine particles in grinding mills before being pumped on flotation cells. In this process, a 40% copper concentrate is produced and returned to the reactor for processing. Our sulfuric acid plant allows us to meet the double challenges of sustainability, reducing our sulfur dioxide emissions while creating a high-quality product. Gas capture hoods are installed above the vessels and allow gas to flow towards our acid plants for cleaning, cooling, and drying. The sulfur dioxide is then converted into sulfuric acid using oxygen and water. Each year, we produce and market 640,000 metric tons of sulfuric acid with the sulfur released from metal extraction. Our clients use this product to manufacture their own products in pharmaceutical, automotive, and food industries. Health, safety, and respect for the environment are our priorities at and beyond every stage of the sulfuric acid manufacturing process, since we offer technical support for distribution and delivery to our customers' doors. An emergency response team is also available to react to any event. Preventive maintenance standards, protocols, and close collaboration with our transporters ensure North American customers that our products will be delivered safely and on time.